I wish I knew why it did that. Will not come right to the screen that I want. Oh well. Good day, 11.5, quadratic functions and their graphs. We went through this, and this will be a review here. I certainly hope you understand what's happening with these. And we're just going to basically sketch them, give a general idea of what the movement is. So the first one is graphing x to the second power plus k. So this indicates that, as I talked about it yesterday, always remember, I'll do it on the side here, that the graph of f of x that equals x to the second power, if we point plot that with a t-chart, I'm not going to do all that, but the graph is going to be centered at the origin, and it'll look something like this. So it's U-shaped. At the origin is the vertex. And the vertex, again, is the lowest point that the graph can possibly go to. So now when we look at an equation or an expression like x squared plus 2, well, that's this expression at 0, meaning x squared plus 0, I could look at it as. But this is plus 2, so this just means we're going to go up 2. And, excuse me a minute. Had to get my black pen for this. So that means we're going to plot it. The vertex is going to be at 0, 2. And then the graph will look something like this. All right, and that'll be for example 2. And when you think about it, if this were in an equation form, do they have it? Oh, that's kind of like how I should write it too. But if I were writing this is f of x equals the x squared plus 2. And then remember, f of x is the same as y. So it's like saying y equals x squared plus 2. And if we were to say when x is 0, what is y? Well, y would equal 2. And so my ordered pair would be 0, 2. And that's the y-intercept here. Or I could say the, y-intercept. Okay, so if I have a graph such as example number 3 here, x squared minus 3, well, that means this graph is going to open upwards, and it's going to be centered at -3. The vertex will be at 0, -3 here. And it'll open up this way. All right. And one more, just for the heck of it. If this graph were negative x squared minus, I'll say minus 1, then this graph would look like, because of the negative out in front, that means it's going to flip and it's going to open downward. And I mentioned that in class. And that would look like, well, x squared minus 1, so it's going to be at -1. The vertex is still at -1, but it's going to open down. And that's the indicator there that it's negative. That tells you to do that. Okay, let's move on to the next objective, next example. Okay, our next example, example 4, we've got, first of all, let's talk about this here as graphing x minus h in parentheses raised to the second power, and how that is different from our first example of x squared minus k, or plus k, if you will. It doesn't matter, plus or minus. We know what to do with that. So the looks in that are entirely different, but yet, sometimes we don't really focus on it in its entirety. So here's a couple examples here. So if we graph f of x equals x squared, well, we know what that is, and that's going to lie at the origin, and it would look something, oh my God, I'll use the yellow, the heck with it. So this is the yellow, and that's the graph of f of x equals x squared. And then if I were to graph the second one, x minus 2 squared, well, that doesn't mean I'm going to go up or down. That means it's going to slide left to right. and then I'm looking at this as saying this is really, the 2 is positive. So, and I talked about this in class, what number makes it 0 in the parentheses? So if x were 2, positive 2, then that tells me the number I have to go to on the x-axis. So the 2 and 2 minus 2, I'd slide the graph over to the positive 2 here, and that's my vertex. And my vertex then is going to be at 2, 0, and the graph here would open up this way, like so. Okay, so if I had, how about if I had x, I could say x minus 2. Shall I do that? X minus 2, and I squared it. Well, if I'm looking at it this way, then I can see it's negative 2, x minus negative 2. But this is also written most of the time as x plus 2, because that's what 2 negatives equal. So again, I could look at it, I like to look at it as what makes it 0 in the parentheses, a negative 2 for the x. So that's where my point is going to be, or my vertex, at negative 2. And then, of course, it's going to open up again as going up. And we talked about if it were negative, what would happen. If this had a negative in front of it, then that would indicate that the graph is opening downward. And then it would look like same point of the vertex, only it's going to be a maximum at that point. But it would open up downward this way. Okay, very good. On to the next one. All right, on to example 7. In example 7, I'm adding, here's our example here. What do I got here? All right, so here's our model to run by. So this is x minus h squared plus k. So we're kind of putting the 2 together that we've had already today. And in this case here, I'm going to address the binomial squared function here, part of the function here. And that means this graph is going to, first of all, I'm going to go 3 to the right. I got 1, 2, 3, but then this 1 tells me I have to shift it up 1. So I'm gonna slide over 3 to the right and then up 1. And this point here is the vertex. And that's the vertex, and I think that's all we have to do yet. We're going to get into the other part soon. Okay, so that means this graph will open up this way here. Remember we talked about the y-intercept, and then we could also throw in the fact that we have the line of symmetry. You know, our U's aren't going to be perfect, as I saw on your examples that we were working on in class, and I have the same problem where I can't draw them perfectly, but I know that this is the vertex, and the line of symmetry is going to go through that line, vertex, and that splits the parabola in half equally, and that's the portion of the graph that is indicating the line of symmetry, where x equals the h. Okay, and now I'll do one more for good measure, and let's say if I had f of x that equals x minus 2, and how about we square that, and it'll be plus 3. So now we're getting to, if we get the hang of this, we're going to see that following our model up here, that h and k are going to be our vertexes. And that tells us what the vertex is immediately, as long as the equation is in that form. So in other words, here I can indicate this is x minus 2, so my x value is going to be 2, and my y value is 3, which is in place of h and k. All right, so if I plot that point I'll go over 2 and up 3 this time. Over 2, up 3, 1, 2, 3. And this is my vertex at this point. And again, it would go and it would open upward as such. Okay, so keep that in mind when we're putting it in this form, our equations in the HK form, that our vertexes are right in front of us. Right, our vertex is in front of us with the H and the K. And just don't get confused about that is not negative 2, it's positive 2. Because how I explained it, they explain it to us in the book as x minus negative 2 is the same as x plus 2. So that's all. All right, in our next example 8, we've got, they want us to, it's a times ax to the second power. Okay, so that means I'm going to have that multiplier in front of it what that is going to do to our graph. So we'll demonstrate this. So I've got graph f of x equals x squared first. So we know what that one is. That's where it's at the origin. The vertex is at the origin, and it's going to open upwards this way. All right, we're okay with that. And then our second equation now is going to be 3x squared. Well, that multiplier 3 is going to lend a little bit of a problem. So what I want to do is I want to take some points here for that. I'm going to plot some points because it's not readily easily done, or it's not too bad, but just so we can see it. So taking 3x squared, that g of x equals 3x squared. 3x squared, that's not written very nice, let me scratch that out, 3x squared, and then I can make a little t-chart here, x and then y. I'll do it this way here. So if x equals 0, y will equal 0. If x equals, so I got this, notice I have the same origin that I'm going to start at. And then if x equals 1, y will equal 3. If x equals 2, then that's going to be, y is going to equal 12. Uh-oh, I'm going to go off my chart already because my graph only goes up to 6. Okay, what else can I do? I can go, how about negative numbers? Let's take a negative number. When x is negative 1, then y is going to be 3. So I got negative, and then if I do negative 2 here, if I got x is negative 2, then that's going to give me 12 as well. So here I've got a few more points then, and let's see if we can find out what happens to the graph because of that multiplier of 3. So here I've got 0, 0, and then I got 1, 3, up 1 over 3. Here, let me change colors here so we can get a good look at this. Up 1 over 3. And then 2, 12. Here's 2, and 12 is way the heck up here. All right, so we can visualize it. Well, you can see it. So it's here's 6, and here's 12 maybe up here. I'll guesstimate it. All right, so this is the right side of this graph. It's going to look something like that. And the other points are going to be, where was I? 2, 12, and then negative 1, 3. I'll go to the left 1 and up 3. And it's just going to mirror, here I've got my vertex going. I'm going to have my line of symmetry. So it's just going to be points that are across from the first set that we made. Notice negative 2, 12. So I'll go over negative 2, up 12. So it'll be up over here somewhere. All right, so then my line is going to come down and complete that vertex then. My line of symmetry is the y-axis, splits it right down the middle. And notice how narrow the graph is because that multiplier of 3. Okay, as opposed to, now we'll do the next one, And how about I'll use green here. How about this next one? Here we go. I've got 1/2 x squared. So 1/2 x squared. Let's do this. X, y. I need some points again for this. So I'm going to say 0, -1, -2, and 1 and 2. Let's try that. We'll just go couple negatives, couple positive because of this parabola. All right, so then I'm going to say when x is 0, y is 0. When x is -1, y is going to be 1/2. When x is -2, when x is -2, y is going to be 4/2, which is 2. When x is 1, y is going to be 1/2. And finally, when x is 2, y is going to be, when x is 2, y is going to be 2 as well. And let's see what this graph looks like. So here I'm starting at 0, 0 again. And then my next point is -1, 1/2, which is about here. -2, 2 is the third point I'm going to use. I'm going to go over 2, and then I'm going to go up 2. -2, 2. And then I've got 1, 1/2, 1, 1/2, which is mirroring the side on the left of the parabola. Then I've got 2, 2, which mirrors the -2, 2. So that's going to be here. And I'm going to take one more because of whatever. I'm going to say when x is -3. If x is -3, what does that make this? That would make -3 squared is 9, and 9 times 1 is 9 over 2. And 9 over 2 is like 4.5. So when x is -3, -3, then y is going to be 4.5, 4.5. So I got 1, 2, 3, and I'm going to go 1, 2, 3, 4.5 about right here. So this line is going to, notice it's flatter as indicated here. All right, so here this narrower one was 3, the whole number 3. That means your parabola is going to be much narrower than when you have a proper fraction. It flattens out then. So that's what's happening with the multipliers of the lead coefficient. Okay. Next up. Okay, our next example is example 9, where they want us to graph -2x squared. All right, and let's see now. Now I'm kind of forced to use a t-chart to find those multipliers, and because my graph is going to be narrower and a little bit more, harder to calculate that or know it right offhand. So I want to plot these points here to say, I'm going to take a couple negative numbers, couple positive, and figure out what the resulting y's are. So let's say if I do, how about 0? Always use 0, right? When x is 0, y is 0. And then I could say when x is 1, y is going to be -2. When x is 2, y is going to be negative 8. Let me make sure on that. 2 squared is 4. 4 times -2 is -8. And I think that's good enough. Let's try now negative 2. And when x is -2, I'm going to get the same y result of -8. And how about 1? So now do -1 at that. So when x is -1, then I'm going to get 1 times -2, which is again -2. So let's see if this is enough to give us an idea what the graph is going to be. So here I've got 0, 0. Let me change colors here. 0, 0. And then I've got 1, -2. over 1 down 2, so that's good because I see it's negative, so that's telling me that's going to open up downward. I've got 2, negative 8. I've got, I'm going to go over 2, down 8. Here's 6, 7, 8 maybe right here, I'm guessing. And now the other side is going to mirror that. So this is the graph here, and it's a little narrower than something that would be 1. A lot of times we just have a positive 1. Let's see, how about negative 2, negative 8? So it's negative 2, negative 8 is down here as well. Again, it's just mirroring the other side. Negative 1, negative 2. So negative 1, negative 2 is here. So this is the graph we're looking for. And a somewhat narrow graph because of the multiplier of negative 2. All right, not too bad. All right. Here's our last example. It's everything involved when we're graphing and sketching these graphs. And it looks like here's my graph here. I'm looking at this is a little bit different with the multiplier in front, but it really doesn't. It's not too bad. It's not bad at all, really, because we have the tools to solve most anything. So what I want to do is I want to basically get my vertex. And remember, we said the vertex was the HK. So this still remains H, and this is K. So let's see, what is that going to be? It's going to be negative 2 and 5. So I'm going to go over 2 to the left because it's negative 2. And then I'm going to go up 5. 1, 2, 3, 4, 5. So here's my vertex. What I don't like about this is it's going to open upwards. All right, so because that's opening upwards, that's troubling me. So I am going to change this problem so it opens downward. So this is going to be negative 1/2. How about if I do that? All right, so then I'll have plenty of room to work going down. All right, so we've got our vertex is still our vertex. And then I've got to find, now it's indicative that I find a point on the y-axis that I can pick out to help me in my sketch. Okay, we don't necessarily have to do the point plotting. That was, kind of like to differentiate from the plane x squared graphs that we have, as opposed to the one where we had the multiplier in front of it. I wanted to point plot that to see the narrowness that's involved. And that is not necessary when the point is off the y-axis. Then I have another point that I can find to draw the line to. All right, so let's see. When I want to find the y-intercept, I have to let x equal 0, and that'll give me the result that I need. So if I've got that, I can draw a set of points like this, or a t-chart, but it's like saying when x is 0, what is y going to be? All right, so here we go. So when x is 0, y is going to be, let's see, I got 2 squared is 4, and 4 times negative 1/2 is going to be negative 2. And negative 2 plus 5 is 3. So that means my y-intercept is at 3 here. Okay. If I want to continue on, so I got 0, 3. And let's say I wanted to continue on, and I wanted to say what are the x-intercepts? What are the x-intercepts? So if that's the case, then I've got a problem such as this, where I'd have 0 equals negative 1 over 2 x plus 2 squared plus 5. And then I have to solve for x. Okay, and we did this yesterday in class, and it was just like huge, right? But let's try it. if I'm going to solve for x here, the first thing I'm going to do is subtract 5. Subtract 5 from both sides. We do have a fraction in it, though. I could have cleared that fraction out, but that's okay. I'll do it on the next step. So it's going to be negative 5 equals negative 1/2 times x plus 2 squared. Okay. And now at this point, I'm going to clear that fraction out. I could divide both by negative 1/2. Negative 5 divided by negative 1/2. You definitely can do that. But I'm going to clear this fraction out by multiplying both sides by 2. Actually, I'm going to multiply both sides by negative 2 to get rid of that negative as well. And that would give me, let's see, if I multiply this side by negative 2 and this side by negative 2, then I'm going to have 10 equals, this is going to be 1 times x plus 2 squared. Move this up a little bit, solving for x. Okay, so the 1 is insignificant, and now I can see I've got x plus 2 squared equals 10. So if I take the square root of both sides here, I'm going to have x plus 2 equals plus or minus the square root of 10. And then I'm going to subtract 2 from both sides, which will make my left side be negative 2 plus or minus the square root of 10 equals x. And boy, we really got a problem now, right? If I'm graphing this, of course, when you're using square roots, you'd have a calculator to help you with that. So that would be the case. But we can see, I can kind of generalize with that, if you will. And of course, we'd have a calculator for a problem like this. But just given that I've got negative 2 plus the square root of 10, well, the square root of 9 is close to 10, so that would be negative 2 plus, I'll just say 3, which is 1. A little bit more than 1, actually. And then negative 2 minus 3 is going to be negative 5. And these are generally about where your x-intercepts are. So let's see if that makes sense. So if I have, what I say it was, 1 would be here, x-intercepts, and negative 5 would be over here. So you can see it's forming our line that we need to give us our sense of direction. If I look at this line of symmetry here, that will help in aiding my point on the other side of this line here. So here's the parabola on the right side. It's going down this way. And the parabola on the left side, I don't want to draw a straight line. So this 3, that tells me here's my line of symmetry. How far away am I from this point on the y-axis? I am actually 2 points away. So that means I have to be 2 points going the other way. There. And then I could finish drawing that off a little bit more accurately. And this is my line of the left side of the parabola. And therefore there's the sketch. All right. And that's the correct way of going about doing that. All right, good enough. And that was our last example for chapter 11.5. Very good. See you in 11.6.